Rahil, and this is Manoj Kumar, and this is Vishweshwaran. We are over here to do a project named as power generation from Chimney. For that, we have taken as this as a model of a chimney. In this, first of all, we are having a thermoelectric generator over here. We are having thermoelectric generator over here, which will change the heat energy and that cold energy into electrical energy. That is, it will convert the temperature difference into potential difference. Like if you just take in the voltmeter, as there is no heat supply over there, but now it's showing around 2.5 milliamps, 2.5 millivolts, as there is no heat supplying over there. But in an original chimney, where there will be around 200 to 400 degree Fahrenheit, it will just take the heat of the chimney, and then it will take the cold energy from the cooling tower, and then convert the temperature difference into potential difference. And then coming to the second one, there is a generator over here, which will just harness the kinetic energy of the gases inside the flue gases inside the chimney. The velocity of the gases inside a chimney is around 20 to 25 meters per second, but in a windmill, the requirement for a turbine to rotate is around 15 kilometers per hour, but it adds around 25 meters per second, so that we can just harness the kinetic energy of the flue gases inside and then convert them into electric energy. Like, if you just check over here, as the light is going over here, because it is just changing the kinetic energy of the gases into electrical energy. So coming to the next point, there is a catalytic converter over here. We are just doing it in a small scale so that it is very basic in model. But if you do it in a chimney, that will be in an advanced model. Like we will be having certain PTF membranes, which will just allow only gases to flow through, but not the liquids to pass through, so that the dust and gases will be filtered over there. And then we are having over here the NaOH solution, which is aqueous NaOH solution, which will convert CO2 into Na2CO3, that is sodium hydroxide, which will combine with CO2, that is carbon dioxide. It will give around sodium carbonate, so that the sodium carbonate will be coming outside in this hole, which will be collected and then sequestrated. But this is only for domestic purpose. If we are using it in industry, there is a chemical named as monoethyl amine. So the monoethyl amine is very, it has a potential of converting around 80 to 90% of CO2 into sequestrated, liquid form CO2. Like it will be, the CO2 will be in liquid form, so that we can take them out, and then we can change that CO2 into valuable product. Like there are carbon ink and then carbon tiles, so that we can change them into carbon tiles or carbon ink, so that we can sell them to the companies. So this is the model of our power generation chimney. This is the way step forward for zero emission in the industries, because now all over the world the zero emission is going around in full stretch, because the atmosphere is just degrading, and then the ozone layer is depleting, so that all the world countries are taking a decision of zero emission, and then Australia is going to it, but India is in the backward step. So this will be a helpful way to do a zero emission. Even though it is a costlier method, it is good for the environment. That's all. Thank you for time. Thank you.